This is higher, it's practice paper E, and we're looking at question 3 in the calculator paper. Okay, question 3 comes in 3 parts. We've got section A, B and also C, which I'll show a bit later. What we've got here is we're going to do part A and B first of all here. Right, so what we've got is we've got a diagram here. We've got a curve that's running through, which is 6x squared minus x cubed, and we've got a straight line, and the equation of the straight line is y is equal to 3x plus 10 sitting here as well. Okay, so what we're starting with is show that x minus 2 is a factor of x cubed minus 6x squared plus 3x plus 10. So let's go ahead and do that first of all. Right, so what I'm going to do is I'm going to set up a bit of synthetic division here, and I'm going to bring down the coefficients here of all the terms. So I've got 1, I've got minus 6, I've got 3 and also 10. Okay, and if I have to show that x minus 2 is a factor, then I'm going to use the root to work out the synthetic division here. And I'm looking for the remainder to be equal to 0. Right, let's do the synthetic division. So bring the 1 down, multiply by the 2. Gather these together and multiply these up to there, so that would be minus 8. And gather these together, so that's going to give me minus 5, and multiply by the 2 will give me minus 10. When I gather these up here, I'll get 0, and that equals the remainder. And if the remainder equals to 0, then x minus 2 is a factor. Okay, so that's the first part complete, so that would be A part 1 done. Hence factorise the x cubed minus 6x squared plus 3x plus 10 fully. Okay, so let's go ahead and do that. So I'm going to write down the starting equation that we've got here. Plus 3x plus 10, and remember what we said, that's going to be equal to, I've got that as a factor first of all, because I've just proven that, and then what I'm going to do is I'm going to take the quotient from here, so that's going to be started at x cubed, so that will be x squared, so that's 1x squared minus 4x minus 5, okay? From there I'm going to factorise it fully for part 2, and here we go, x minus 2, I've got put this into 2 brackets, x and x, I've just got 5 and 1, I can see the biggest is a minus and the other one's a positive, okay? Right, so that would be factorised fully to there, so that's the final part's done. Right, let's look at part B, okay, and we'll go ahead and do that. So the line with equation y is equal to 3x plus 10, this line here, intersects the curve with equation y is equal to 6x squared minus x cubed. So there's the intersections, the 3 points, A, B and C. So find the x coordinates of the points A and C. Right, let's go ahead and do that one. Right, so for the points of intersection, what I'm going to do is I'm going to let y equals y. Okay, so all I'm really going to do is let the line equation equal the curve equation. Okay, and that's all I'm doing. That's all I mean by y equals y, because I've got y equals and y equals there. Right, so let's set this up right away. So I've got 3x plus 10, that's the line, and on the other side I'll put the curve. 6x squared minus x cubed. I'll gather everything over on the left hand side, so what I'll have is x cubed, I've got minus 6x squared, I've got the plus 3x and the plus 10 at that side, and that all equals 0. Okay, and then what I have to do is I'm going to try and factorise that. So if I look back at the work I did in part A, I already had this here, this equation, so what I'll do is I'll just use the factors that have come out of that there, and that's really why I had to do part A. So let's put the factors in here. So that'd be x minus 2, x plus 1 and x minus 5 coming out from there. Right, so next thing I'll do is I'll solve this part. So I've got x minus 2 equals 0, so I've got x equals 2. I've got x plus 1 equals 0, so x equals minus 1, and x minus 5 equals 0, so x equals 5. So it's the x coordinates that I just have to find out for the points A and C. Now if I look at the diagram, A is the furthest left. So I'd be expecting that the point there is going to be the furthest left x coordinate that I've got. So the x coordinate of A, so x coordinate of A, let's go for a capital on that one, A is, and we'll go for the furthest left would be the -1. It's x equals -1. And what we'll go for is the x coordinate of, and it's C is the next one that I have to work out, and that's going to be x is equal to, so it'll be the furthest right point, so that would be the 5, okay? So x is equal to 5 there. And that's parts A and B complete. Let me show the marks for parts A and B first of all, and then we'll move on to part C. Okay, so what I'll do is I'll give 1 mark for setting up the synthetic division, and I'll give 1 mark for a statement that says that 0 is the remainder and therefore the x minus 2 is a factor. So there's 2 marks there. I'll go for a mark for getting the quotient down into there, and then for factorising fully would be the 2 marks there. So that there is out of 4 marks part A. For part B, what I'll do is we'll go for 1 mark for letting the line and the curve equal each other to try and solve them. And from there we'll go for the, we'll go for getting x is equal to 2, -1 and 5, and then from that getting a statement that clearly says what the x coordinates of A and C are. Okay, so that would be 3 marks there. So what we'll say is that's out of 4 on the top for part A. This one here is out of 3. Okay, so that's 7 marks in total so far. Okay, let's have a look at the next part of the question. Okay, so what we have here is we have the area between the curve and the line from A to C is shaded in the diagram. Okay, calculate the total shaded area shown here. Right, so what we've got is we've already got the points that we have here for A, B and C. We know the x coordinates of that. So what I can do is I can integrate, and I'll know the limits that I'm going to use. So let's work out the area of BC first of all. Okay, so the area, and it's BC that we're working out, is going to be integrated between, let's see, so C was 5 previously, in the first part, and B was 2. Right, so they're the limits, and what I'm going to do is I'm going to be working between the upper and I'm going to subtract the lower from that, and that's all going to be with respect to x. So what we'll do is I'll substitute these values in first of all. There's the 5 and the 2 still there. The upper is this part here, the upper part of the area, which is the curve. Okay, so that's going to be 6x squared, and it's minus x cubed. That's the upper part. Just put them in brackets so that we don't lose this minus that's here. And the lower is going to be the line, which is 3x plus 10. And that's all with respect to x. Right, so let's just sort some bits out here first of all. So what I have is 6x squared minus x cubed. I've got minus 3x and minus 10. And that's all with respect to x. So I'm ready now to integrate. Right, going ahead to integrate now, what we have is raise the power up by 1 and divide by the new power. So I've got 6x cubed all over 3 minus x to the power of 4 all over 4 minus 3x squared all over 2, and I've got minus 10x. The limits that I'm going to substitute in are going to be 5 and 2. Okay. Right, so what I'm going to do next of all is I'm going to substitute a 5 into all of this, then I'm going to subtract 2 being substituted in there. Right, let's go ahead and do that now. So the first part is the 5 going in. 6 divided by 3 is just 2, so that's just going to be 2, and I'll put a 5 cubed, minus, I've got 5 to the power of 4 all over 4, minus 3 to the power, and that's going to be 5 to the power of 2, all over 2, and minus 10 times 5. So that's just 5 going into this whole equation that I've got here. I'm then going to subtract from that the 2 substituting in. So I've got 2 cubed minus 2 to the power of 4 all over 4 minus 3 times 2 to the power of 2 all over 2 and minus 10 times the 2. Okay, and that's us got that sorted out. It is a calculator question, so just put this into your calculator and work it through. What I'm going to do is I'm going to do either side first of all and work these out. So this part in the bracket here will work out to be 25 upon 4. It's going to subtract, and this part here works out to be minus 14. When I gather that together, that should give me 81 over 4 units squared. Okay, and remember that's just for the area between B and C, so that'd be that shaded area that's there. What I can say here is that due to symmetry, I'm going to say that the area of between AB is going to be equal to the same. So that area there and that area there are just going to be the exact same. So that's going to be 81 over 4 units squared. And then from there, I'm just going to work out the total area. So total area is going to be equal to, and it's going to be 81 over 4 plus 81 over 4, which is going to give me an answer of 81 over 2. Okay. Units squared, and that would be the question complete. Now what you could do is you could work out the area of B to C and then work out the area of A to B, and what you'll get is you will get the same value, which will be 81 over 4, okay, coming out from there. Okay, so let's go ahead and see the marking for this question. Right, first mark will be for knowing to integrate. So knowing to integrate and knowing that it's the upper take away the lower. For the second mark, what we'll do is we'll just get for substituting these in and also having the limits included in that. I'll go for the next mark for integrating, so that'll be this mark here. Next mark for substituting in, okay, the values of 5 and the value of 2, or if you've done it the other way around, the value of 2 and the value of minus 1. And then for getting the first area, or for one part of it. Next one, what we'll do is get 1 mark for this area here, and if you have worked it out the same way with the other limits, then you'll get 1 mark for that. And finally, the total area will be our 7th mark on that one. So total marks out on this one out of 7. Remember there were marks for question part A and B, and they were 4 marks and 3 marks, so that's going to be a total of 14 marks that we're getting for this question here.